Now let's go and read this Mark's dev blog called Blogged Answers: Why React Context is not a state management tool and why it doesn't replace Redux. So it is from 2021. So let's read more about this. Introduction. Context versus Redux has been one of the most wildly debated topics within the React community ever since the current React Context API was released. Sadly, most of this debate stems from confusion over the purpose and use cases for these two tools. I've answered various questions about context and Redux hundreds of times across the internet, including my posts. Redux not dead yet. Redux, the context behavior, a mostly complete guide to React rendering behavior, and when not to reach for Redux. Yet the confusion continues to get worse. Given the prevalence of questions on this topic, I'm putting together this post as a definite answer to those questions. I'll try to clarify what context and Redux actually are, how they're meant to be used, how they're different, and when you should use them. Too long didn't read. Are context and Redux the same thing? No, they are different tools that do different things, and you use them for different purposes. Is context a state management tool? No, context is a form of dependency injection. It is a transport mechanism. It doesn't manage anything. Any state management is done by you and your own code, typically via the useState, useReducer hooks. Are context and useReducer a replacement for Redux? No, they have some similarities and overlap, but there are major differences in their capabilities. When should I use context? Anytime you have some value that you want to make accessible to a portion of your React component tree without passing that value down as props through each level of components. But can't we just use the component composition for this? When should I use context and useReducer? When you have moderately complex React component state management needs within a specific section of your application. When should I use Redux instead? Redux is most useful in cases when you have larger amounts of application state that are needed in many places in the app. So once again, Redux is most useful in cases when you have larger amounts of application state that are needed in many places in the app. Okay, and context is state management needs within a specific section of your application. Okay, so the app state is updated frequently over time. The logic to update that state may be complex. The app has a medium or large sized code base and might be worked on by many people. You want to be able to understand when, why, and how the state in your application has updated and visualize the changes to your state over time. So I guess that this is where the advanced debugging tools of Redux come in. You need more powerful capabilities for managing side effects, persistence, and data serialization. Table of contents, so let's skip that. Understanding context and Redux. In order to use any tool correctly, it's critical to understand what its purpose is, what problems it is trying to solve, when and why it was originally created. It's also critical to understand what problems you are trying to solve in your own application right now, and pick the tools that solve your problem the best. Not because someone else said you should use them, not because they're popular, but because this is what works best for you in this particular situation. Most of the confusion over context versus Redux stems from a lack of understanding about what these tools actually do and what problems they solve. So, in order to actually know when to use them, we need to first clearly define what they do and what problems they solve. What is React context? Let's start by looking at the actual description of context from the React docs documentation. Context provides a way to pass data through the component tree without having to pass props down manually at every level. In a typical React application, data is passed top-down, parent to child, via props. But this can be cumbersome for certain types of props, like locale, preference, UI theme, that are required by many components within the application. Context provides a way to share values like these between components without having to explicitly pass a prop through every level of the tree. Notice that it doesn't say anything about managing values. It only refers to passing and sharing values. The current React Context API, React.createContext, was first released in React 16.3. It replaced the legacy Context API, which had been available since early version of React, but had major design flaws. The primary problem with legacy context was that updates to values passed down via context could be blocked if a component skipped rendering. Okay, I don't care about that. I don't care about legacy. So create context was designed to solve that problem so that any update to a value will be seen in child components even if a component in the middle skips rendering. Oh, okay. Okay, I think I understand. Using context. Using React context in an app requires a few steps. First, call const myContext React create context to create a context object instance. In a parent component, render myContext.provider and then the value. Oh, okay, this is like roots, like a React router. This puts some single piece of data into the context. That value could be anything: a string, a number, an object, an array, a class, instance, an event emitter, and so on. Then, in any component nested inside that provider, call const the context value equals use context myContext. Okay, this seems simple enough. Whenever the parent component re-renders and passes it a new reference to the context provider as a value, any component that reads from that context will be forced to re-render. Okay. Most commonly, the value for the context is something that comes from React component. So most commonly, the value for a context is something that comes from React component state along these lines. So let's take a look. Function parent component has counter and set counter state. So create an object. Create an object containing both the value and the setter, context value, counter, and set counter. So return my context provider value, context value, this one. And yeah, so the SomeChild component will be provided by these two. This value, which holds the counter and set counter. Okay, this makes sense. A child component can then call useContext to read the value. So nested child component has this again state. Okay, this is interesting because we have the two identical states now. This one is 0 and this one is referenced in my context. Okay. Okay, so use context, my context. But it did not access this context value. Okay, purpose and use cases for context. Based on that, we can see that context doesn't actually manage anything at all. Instead, it's like a pipe or a wormhole. You put something in the top end of the pipe using my context provider, and that one thing, whatever it is, goes down through the pipe until it pops out the other end where another component asks for it with use context provider. So the primary purpose for using context is to avoid prop drilling. Rather than pass this value down as a prop explicitly through every level of the component tree that needs it. Any component that's nested inside the context provider can just say use context, my context, to grab the value as needed. This does simplify the code because we don't have to write all the extra prop passing logic. Conceptually, this is a form of dependency injection. We know that the child component needs a value of a certain type, but it doesn't try to create or set up that value itself. Instead, it assumes that some parent component will pass down that value at runtime. Okay, and now what is Redux? For comparison, let's look at the description from the Redux Essentials tutorial in the Redux docs. Redux is a pattern and library for managing and updating application state using events called actions. It serves as a centralized store for state that needs to be used across your entire application, with rules ensuring that the state can only be updated in a predictable fashion. Redux helps you manage global state that is needed across many parts of your application. The patterns and tools provided by Redux make it easier to understand when, where, why, and how the state in your application is being updated, and how your application logic will behave when those changes occur. Okay, note that this description specifically refers to managing state, and that it also says that the purpose of Redux is to help you understand how state changes over time. Historically, Redux was originally created as an implementation of the Flux architecture, which was a pattern first suggested by Facebook at 2014, a year after React came out. Following that announcement, the community created dozens of Flux-inspired libraries with varying approaches to Flux concepts. Redux came out in 2015 and quickly won the Flux wars because it had the best design, matched the problems people were trying to solve, and worked great with React. Architecturally, Redux emphasized using functional programming principles to help you write as much of your code as possible as predictable reducer functions, and separating the idea of what event happened from the logic that determines how the state updates when the event happens. Redux also uses middleware as a way to extend the capabilities of the Redux store, including handling side effects. Redux also has the Redux DevTools, which allow you to see the history of actions and state changes in your app over time. Redux and React. Redux itself is UI agnostic. You can use it with any UI layer: React, Vue, Angular, Vanilla.js, and so on. or without any UI at all. So that said, Redux is most commonly used with React. The React Redux library is the official UI binding layer that lets React components interact with a Redux store by reading values from Redux state and dispatching actions. So when most people refer to Redux, they actually mean using a Redux store and the React Redux library together. React Redux allows any React component in the application to talk to the Redux store. This is only possible because React Redux uses context internally. However, it's critical to note that React Redux only passes down the Redux store instance via context, not the current state value. This is actually an example of using context for dependency injection as mentioned above. We note that our Redux connected React components need to talk to a Redux store, but we don't know or care which Redux store that is when we define the component. The actual Redux store is injected into the tree at runtime using React Redux provider component. Okay, it would be much easier to just say that it is using the provider the same way that the context is using it. So it is wrapping things in a provider. It's much easier to understand. Because of this, React Redux can also be used to avoid prop drilling. Specifically because React Redux uses context internally. Instead of explicitly putting a new value into a myContext provider yourself, you can put that data into the Redux store and then access it anywhere. Purposes and use cases for React Redux. So it's a little bit different. The primary reason to use Redux is captured in the description from the Redux documents. The pattern and tools provided by Redux make it easier to understand when, where, why, and how the state in your application is being updated, and how your application logic will behave when those changes occur. Now, there are additional reasons why you might want to use Redux. Avoiding prop drilling is one of those other reasons. Many people choose Redux early on specifically to let them avoid prop drilling, because React's legacy context was broken and React Redux worked correctly. Other valid reasons to use Redux include wanting to write your state management logic completely separate from the UI layer. Wanting to write your state management logic completely separate from the UI layer. Sharing state management logic between different UI layers, such as an application that is being migrated from Angular JS to React. Using the power of Redux middleware to add additional logic when actions are dispatched. Being able to persist portions of the Redux state. Enabling bug reports that can be replayed by developers, and faster debugging of UI, of logic and UI while in development. Dan Abramov listed a number of these use cases when he wrote his post, "You might not need Redux," all the way back in 2016. Okay, so why context is not state management? State is any data that describes the behavior of an application. We could divide that into categories like server state, communication state, and location state, if we want to, but the key point is that there is data being stored, read, updated, and used. David, the author of X State Library and an expert on state machines, said, "State management is how state changes over time." Based on that, we can say that state management means having ways to store an initial value, read the current value, and update the value. So create, read, and update. There's also typically a way to be notified when the current value has changed. React's useState and useReducer hooks are a good example of state management. With both of those hooks, you can store an initial value by calling the hook, read the current value also by calling hook, update the value by calling the supplied setState or dispatch function, know that the value has been updated because the component re-rendered. Similarly, Redux and MobX are clearly state management as well. Redux stores an initial value by calling the root reducer, lets you read the current value with store getState, updates the value with store dispatch action, and notifies listeners that the store updated via store.subscribe listener. MobX stores an initial value by assigning field values in a store class, lets you read the current value by accessing the store fields, updates values by assigning to those fields, and notifies that changes happened via auto-run or computed. We can even say that server caching tools like React Query, SWR, Apollo, and RQL fit the definition of state management. They store initial values based on fetched data, return the current value via their hooks, allow updates via server mutations, and notify of changes via re-rendering the component. React Context does not meet this criteria. Therefore, React Context is not a state management tool. As we established earlier, context does not store anything itself. The parent component that renders my context provider is responsible for deciding what value is passed into the context. And that value typically is based on React component state. The actual state management is happening with the useState useReducer hook. As David also said, context is how state that exists somewhere already is shared with other components. Context has little to do with state management. Or, as I recently put it, I guess context is more like hidden props than abstracted state. Think of it this way. We could have written the exact same useState reducer code, but prop drilled the data and the update function down through the component tree. The actual behavior of the app would have been the same overall. All context does for us is let us skip the prop drilling. Comparing context and Redux. Let's review what capabilities context and React plus Redux actually have. Context does not store or manage anything, only works in React components. Passes down a single value, which could be anything, primitive, object, classes, and so on. Allows reading that single value. Can be used to avoid prop drilling. Does show the current context value for both provider and consumer components in the React DevTools, but does not show any history of how that value changed over time. Updates consuming components when the context value changed, but with no way to skip updates. Does not include any mechanism for side effects. It's purely for rendering components. And now React plus Redux stores and manages a single value, which is typically an object. Works with any UI, including outside of React components. Allows reading that single value. Can be used to avoid prop drilling. Can update the value via dispatching an action and running reducers. Has DevTools that show the history of all dispatched actions and state changes over time. Uses middleware to allow app code to trigger side effects, and allows components to subscribe to store updates, extract specific pieces of the store state, and only re-render when those values change. So clearly, these are very different tools with different capabilities. The only overlap between them really is that it can be used to avoid prop drilling. But I guess if we need it just for that, we should use context. Okay, let me do this one. Context and use reducer. One problem with the context versus Redux discussion is that people often actually mean I'm using use reducer to manage my state and context to pass down that state. But they never state that explicitly, they just say I'm using context. That's a common cause of the confusion, I see. And it's really unfortunate because it helps perpetuate the idea that the context manages state. So let's talk about the context plus use reducer combination specifically. Yes, context plus use reducer does look an awful lot like Redux plus React Redux. They both have a stored value, a reducer function, a dispatching of actions, a way to pass down that value and read it in nested components. However, there is still a number of very significant differences in the capabilities and behaviors of the context plus use reducer versus those of Redux plus React Redux. I covered the key points in my post and the names of the post, summarizing here. Okay, but we're gonna summarize here once again. Okay, and this will be part 1. I don't want to be more than 30 minutes long, so this is part 1. Next video is part 2, where I continue this.